Hello friends, welcome to my channel. In this video, I will cover fluid mechanics, most important MCQs for SSC. This is part 2. Question is, Poise is a unit of dynamic viscosity. V. This is mu. This is CGS unit. CGS unit is Poise, and SI unit is Pascal into second, or you can call it as Newton per meter square 1 Pascal into second, or Newton is 10 to the power 5 dyne divided by 10 to the power 4 centimeter square into second. So finally we will get 10 dyne per centimeter square into second. Dyne per centimeter square into second is your Poise. So 1 Pascal second equal to 10 Poise, or you can write it as 1 Poise equal to 0.1 Newton per meter square into second. This unit conversion also so many times they are asking in other exam also. So this is very important. This is unit for dynamic viscosity. Like this, for unit of kinematic viscosity also very important. We know kinematic viscosity is dynamic viscosity mu by rho, mass density. Its unit is, SI unit is meter square per second, and CGS unit is your stroke. This unit conversion also very important. Meter square per second is 10 to the power 4 centimeter square divided by second. 1 centimeter square per second is 1 stroke. So 1 stroke also you can write it as 10 to the power minus 4 meter square per second. SI to CGS conversion or CGS to SI conversion. Both are important for Poise and stroke. Here this is stroke. Both conversion are important, Poise and your stroke. The intensity of pressure at a depth is H equal to, we know pressure P equal to rho g H. H is depth and rho g is your specific weight into H. So from option A is your answer. Question is, the resultant pressure P of the liquid on a immersed surface will act at H star, or center of pressure. So from option A, point of center of gravity, no. Center of gravity we can call it as X bar or H bar. The lower edge of the surface, no. Upper edge of the surface, none of the. D is your answer. The depth of center of pressure, H, is how much? So if a body is like this, vertical surface, you have to calculate its H star. Let this is G point CG, this is X bar. H star will come below your CG point. H star, as for this question, it's H. So H formula is H equal to IU divided by X bar A plus X bar. Here in option, this portion is missing. I think some printing mistake. B is your answer. It should be plus X bar. In case of inclined surface, H will come IU sin square theta divided by AX bar plus X bar. And one thing you should remember, it's always below the center of gravity point. Question is, the pressure of fluid can be measured by a barometer, correct, gauge pressure, barometer for gauge pressure, manometer, pressure difference, then piezometer, small pressure measurement. This is also we are using. Static pressure also you can use by piezometer. So all of the above, D is your answer. The point of application of buoyant force is known as center of pressure, already discussed. This is the application point of resultant force. Resultant force. So application of buoyant force is center of buoyancy. And one more thing is important here. This buoyant force, it should always act through the centroid of the liquid displaced. It will not act the center of gravity of the body. It will act through the centroid of the liquid displaced. Body is said to be floating. This is the liquid surface. Body is floating. So here W is at CG. W will act, and FV, it will act upwards force of buoyancy. So here body should be floating, so upward force FV should greater than W. If body is submerged, then W is greater than FV. So from option body is floating, C is your answer. According to principle of flotation, the weight of liquid displaced as compared to the weight of the body. Principle of flotation. Again, this is the surface of the liquid. Body is floating. Let this body is floating. And for principle of floating, W at CG point, let this point here CG point, W will act downwards, and this point is center of the displaced fluid, center of gravity of the displaced fluid. Let this point FB will act here. For flotation, principle of flotation, W should equal to force of buoyancy. So here W is volume of the body, total V into rho G of body. It's equal to FV. This is volume of the fluid displaced, this volume only. This volume. Volume of the fluid displaced into rho G of fluid, surrounded fluid. So GG you can cut. Rho V of the body. This is for body. It's equal to volume of fluid displaced into density of the fluid. This is condition for principle of flotation. So it's same. And we know force of buoyancy, it's equal to weight of the liquid displaced. So volume of the fluid displaced into density of fluid into G. Stability of the floating body depends on stability of floating body. That condition is always important. First your metacenter will come, then G, center of gravity, then buoyancy force point, center of buoyancy B. M should be above of G. So here mg is metacentric height or gm is metacentric height. This is important for stability of the floating body. So C is your answer. If M point will coincide with G point, then body will be in neutral equilibrium. Neutral equilibrium. And if M point is here below G point, then it's unstable. And for stability, M should be above G. Next two questions: metacentric height of sailing ship and metacentric height of battleship. Here for ship, the time period is very important. Time period T is 2 pi root over K square divided by G into Gm. Gm is your metacentric height. So from this equation, time period T is inversely proportional to Gm root over. For ships, two conditions are important. comfort condition and your stability condition. In battleships, stability is your priority. This should stable, and in case of sailing ship, comfort is your priority. So in case of comfort, your time period should increase. Time period should increase means GM it should decrease. And in case of battleship, stability is important. So time period should less and your GM it should increase. It should increase. So from option we will check. For sailing ships, GM should less. So for sailing ships, A is your answer. And for metacentric height of battleship, metacentric height is GM. For battleships, it's greater than sailing ships. So 1 meter to 1.5 meter. Question is, a manometer is used to measure velocity of flow in a channel? No. Atmospheric pressure? No. Then pressure in pipes? C is your answer. This is the end of part 2. Thank you friends. Thank you for watching my video. Thank you.